Hello guys, welcome back to online class for excellence. I Icse will guide you guys through physics subject and like sound chapter. So I guess you guys have seen my last video. If you have any problem, you can contact me. You can write in the comment section as well for the mathematics part. But now it's time for physics, and the next chapter that is I will go through in this video is sound. So first, what we need to know is, like, you guys are having your examination, they are being postponed due to corona and all. Every board and every central examinations as well, that all we know. But still, you guys have to carry on the preparation for the for your future only. So for the time being, we will go with the physics sound part. So what is reflection? It's same as, if you guys know the light part, that will be my next like video for the physics. So reflection is like when sound is falling on a surface, it is getting reflected back to again like that medium. So when the sound is getting like scattered, like this is a sound is coming over here and it's getting reflecting back. So it is basically reflection. So as I'm telling, like light and sound, so both these are energy, nothing else. They are both energy. Sound energy, the energy that is being produced, which makes us unable to hear, and light is like the energy that makes us able to see. So over here sound, and what we need to know over here is like the first main thing over here, as this reflection I have drawn. Look, sound is basically energy that enables us to hear. So what is the main its characteristics? So first that will come over here will be echo. Echo like physics. So like this, the echo is coming. So like this is a practical demonstration. So for the time being, echo is like when the echo is a repetition of sound due to this reflection of the sound. So like the repetition is happening because of the reflection. So this is called echo. So time means like what is the time? Like if I'm like the source of the sound, I'm standing in front of a hill, and like I'm standing on a hill, and in my front there is a hill. So I'm like calling my name like Prithviraj, and the name is coming back over to me. So that is an echo. So how much time it is taking? So basically this is the time. That the distance is like from the surface, that is the reflection is happening. So like this is falling over here, this is coming over here. So if the main source and the observer is over here, so source is giving the sound and observer is raising the sound. So what is the time? That is this is the time that the sound wave is taking. What is the distance? The distance between this part, like this two and this part. So this is the distance. I will come back to this like for the numerical part. And the nature and size of like the surface, what is the nature of the surface? Like what is the nature of the surface? Where is the sound is falling on, and the size, how much size, the surface area. The surface area basically. So multiple echoes means, suppose there are multiple like barriers, like one person is standing over here and shouting out, and like it is keeping on like reflecting on and reflecting on and reflecting on. So basically this multiple echo happens like when you hear basically in hills, when you call out your name or call out your any favorite word, you hear multiple echoes, like it keep on reverberating. And use of echoes, what is the use of echoes? There is the sonar and bat. And so what is sonar and what is bat? So sonar is like it's basically a case of submarine. So when the submarine comes, like this is the sea surface, and submarine is when it comes under the surface. So basically what happens, if it needs to find the surface, like how much is the distance of the surface, so it radiates a sound wave, so it comes back again to the receiver of the submarine. So they can calculate like what can be the distance between the submarine and the surface, because at like as you can say, like 340 meter per second is the speed of sound in air. So in water it varies a little bit, but these guys can calculate it and find the distance between the submarine and the surface. And bats, they use it for they use the ultrasonic sound, so that they can get if a prey is in front of it. If a prey is in front of it, prey in the sense like hunting, in the time of hunting at night, they release an ultrasonic wave. We can't hear it because, as you can know, sound, we have a definite hearing perception. Like we have a normal frequency, we can hear a normal frequency. But it is ultrasonic sound. Ultrasonic sound is beyond our frequency, so our ears can't hear this voice. this sound, and like the bat is keeps on giving this ultrasonic sound, and if it reflects back to it, if it can hear its own sound, it can guess like something is in front of it and it is a prey of it. And I will come back lastly in the like most part, like a person clapped hands after echo. This is a like summation. A person clapped hands and heard an echo after 5 seconds from the distance of the cliff and person. So maybe we consider this is the person and this is the cliff. So I will come back to the main thing. Like if this is a person, this is for numerical guys, and this is a like surface that can get him from he will like give the sound wave over here, and the echo will come back from this surface. So from here, let this distance between the source and the the main part with the main surface be d. And if you guys know, you guys also know as well as v. V is take it as sound, like sound velocity, sound speed. Alright, and the time, t is the time, that the time is needed for the receiver to hear the echo. So over here, so person clapped hand and heard the echo after 5 seconds on the distance of the cliff and the person. So let's take this distance as d. So what is the formula basically for this time? I have written this as in caps only, in caps. Why? Because time is nothing but time equal to distance by speed. Distance by speed. Why I'm writing like 2d? 2d I have written because the sound is traveling from this point to this point. Again, it is traveling from this point to this point. So if it is d, so d plus d is 2d. So this is the main formula. Alright. So this you have to know for the time formula. Over here also find the distance. So distance is nothing but, as you can see over here, distance is like d equal to t by 2t by st by 2. So distance is over here. So what is echo? It is heard after t is over here 5. Alright, find the distance, and sound is given over here. So what is the main thing? D. So we can conclude from here over like t is equal to 2d by s. So d will be equal to st by 2. st by 2. So s is equal to the speed of the sound that is given over here. T is the time that is given over here, and 2 is the why d is by 2. Like over here, as you can see, why 2d, as the sound is going from this end to this end, then is again coming back to this end to this end in order to produce the echo. So basically this is 2d by t. So next part I will be coming back with the main free vibrations and all, and amplitude, and what are the characteristics of sound, resonance and all. I will come back with some problems as well. Till then guys, you can note it down, you can pause the video, you can note everything that you guys need for your examination, because the examination is near. Till then guys, I will come back with the numerological problem. So the next part of sound guys, free vibration. So what are the types of vibration? What is vibration? Like when you apply an external force, then our body start vibrating. Like if I have a ball in my hand, I will drop like this and it will start vibrating. So that is the vibration, the movement, the vibration is producing the sound. When I'm dropping the ball, the sound is being produced. So what is the vibration and how many types of things are there that you need to understand before I come again to the main numerical part are these subjects. So these topics. So number one, free vibrations. What are free vibrations? Equilibrium position is disturbed. Like normal, like suppose something I'm dropping something from it drops from a table, an object, and it goes on like simple vibrating in its own position. So it is free vibrations. Equilibrium position is disturbed. Like suppose this is the equilibrium position, and it is disturbed in the sense like it is following a definite pattern and is moving over like this. As I told you, sound can move in a medium. Sound need a medium to move. It is exception from light. Light doesn't need a medium, but sound need a medium. So over here, equilibrium. This is the equilibrium position, and it is being disturbed. So this is a free vibration. The body is vibrating, and it is constant. The vibration is being constant until and unless in case of an external force. Like an object is moving like this. I apply an external force over here, and the vibration stops. Then it's different thing. It is not free vibration. That is the next part that I am coming over here. So free vibration means the body, any object is like going on like this and this, like any machinery, like a constant speed is being maintained. And So like again, if it is not constant in absence of external force, I am applying a force, it will stop. So it's a different thing. So now I will come over here, the field vibrations. This formula you guys need to remember in case of different objects. Like in case of pendulum, the time that is needed for one complete oscillation. Like the object is starting from here and is coming to here. So one complete oscillation is being happening. So the time needed for this one complete oscillation is the time period T. T is the time period. So 2 pi Lg in case of pendulum. L is the length of the pendulum, and G is the acceleration due to gravity. And in case of spring, T is 2 pi root over m by k. K is the constant of spring that you can get in your sums. They will give you. Generally, we can take it as k equal to 1 as well. And m is the load that is the spring is being holding. Guitar or any string instrument, it has the first frequency, the natural frequency V over here, like the string, because like one vibration is happening, so the natural frequency is V. Then two vibrations is happening, then is 2V. So the natural frequency, the initial, like when you strum the guitar or strum any instrument, the first frequency that is being produced, that is V. V is equal to 1 by 2L. L is the length. T is the time period and m is the mass of the thing, and you can say m is pi d as well if you apply the formula density equal to mass by area. So in that case, and like the natural velocity, this natural velocity is called fundamental tone. The first frequency that is being heard, then it comes again, then it keeps on continuing, then the overtones coming. So this is the fundamental frequency V, then 2V, this is overtone, 3V, 4V is going on. So these are the overtones and this is the fundamental frequency. Then the damped vibration, as I told you, if a ball is going on and I'm holding it, I'm applying an external force in order to stop it. So the equilibrium, the vibration will happen like this, it will slowly come to an end. So this is called damped vibration, as I've told you over here. This is happening in case of when this is a presence of external force. Then force vibration, like a body is in equilibrium, but I am applying external force so that it will move. So force frequency different from natural frequency. So basically when I am applying a force in the body, suppose a big rock is over there, I am not being able to move it. So I have to possess a particular frequency, I have to possess a particular mass in order to move that thing. So when that force frequency, the frequency of the force that I am applying, and the natural frequency, like if the body is moving on in its natural way, the natural frequency, so these two are different. When the force frequency, the frequency of the force and the natural frequency of that object is different, so it will cause force vibration. So this is force vibration. Resonant vibration means it is the same, like when this, it is a main difference from the force vibration and the resonant vibration. Mind it guys, resonant vibration is like when the force frequency is same as the natural frequency, like the same, the force is applying, the frequency and the natural frequency of the body is same. So the force is not like having any problem in order to make it vibrate. So this is resonant vibration. Resonance, the phenomenon is resonance when a body vibrates, when the external force frequency is same as the natural frequency of an object, it produces resonant vibration, and the phenomenon is known as resonance. Same, and like tuning fork, like this, when these two are the tuning forks and of same frequency. So if I strung it over here, it will start producing sound and it will go over here, the air, a medium, it will go over here, and after some time this will also start vibrating. This will also start vibrating, and the vibration, the net frequency of the vibration of both A and B, these both tuning fork will be same. This is called resonance. Yeah, good example, you can note it down guys. Then you have to do a little bit theoretical part, noise pollution. This you can guys reading from any textbook you have, how noise pollution is being caused, what is noise pollution, how you can curb it down. And now over here, number 4, what are the characteristics of a sound? What are the characteristics? You guys have to remember some of the topics that I will cover right now. So number 1 is loudness of a sound. Loudness is expressed in decibel, dB. Like how loud sound or low sound that you guys are percepting through your ears. So that is the loudness of a sound. But it depends upon basically the amplitude of the sound. How much more than if a loud sound is coming, I feel like generally of loud sound. Like a low tone, fine, a softest tune. So this is loudness, and in dB, L is the loudness, like you can say the notation. 10, log 10, I and I0, and these are the intensity. Intensity is the next topic, that the characteristics. The next topic is intensity. So I0 is the initial intensity, and I is the intensity that we are measuring when we are measuring the loudness. So intensity is nothing but like it's an energy, it's basically energy like that is being produced over a area. So W equal to energy watt and m to the power -2, that means like W by m square. So intensity is basically energy, like the energy is being produced when a sound is vibrating, is going on and the object is vibrating. So I equal to, these are the factors that you guys need to know for the theoretical part. Intensity is directly proportional to the a square. A square is the square of the area on which the intensity is like the body is vibrating. Then I is inversely proportional to 1 by d square. D square is like distance, like the main distance from the equilibrium position. Like it is moving from the main equilibrium position, how much, like how like the distance is being produced, or mainly like the distance depends upon the source and the recipient as well. How long is the distance from the source production and the recipient? So that is the D. So you can guys can guess like it's because like when the distance is like lesser, the sound will be, the intensity of the sound will be more. So at the surface area, as I told you, the surface area, and over here density. And one more thing guys, like as surface area over here, you can guys like use it for another formula as well. A square, you can say amplitude. So amplitude means, as I told you, the amplitude determines the loudness. So intensity is nothing but depends upon the amplitude only, how much amplitude is coming. So it is basically the this part are being the main factors that that determines the intensity. Then pitch is how much shrill or soft is the voice, like the pitch. So it depends upon frequency. How much is the frequency? The more the frequency, the pitch will be higher. The lower the frequency, the pitch will be lower. Then comes the quality, music or noise. I have given this two part because quality determines when like which sound is music or which sound is noise. Like that is pleasant to your ear or it is being no, it's harmful to my ear. That is the quality. That it is also known as the timbre. It happens when the pitch and the pitch and the intensity, the loudness, this pitch and intensity, these two things are same. Then comes the quality. It determines if these two things are same, then how you guys will come to know like which is different, how is it different. So then comes the quality. It determines like whether the sound is good or bad. So this is, then comes the music and the noise, the differentiation. This is basically the theoretical part guys. Now I will come back with some numerical problems as I've given in my previous classes as well. I write down the problems guys, I will tell you the answer as well, I will tell you the process, then you guys have to write it down and do the sums and tell me in the comment section. Then wait guys till I come back with the numerical problems. So these are some numerical problems regarding sound, the last part of this video. The ratio of amplitude of two waves is 4:9, ratio of their intensities. So as you know, as I told you, there is a formula, intensity directly proportional to a square. A is the amplitude over here. So 4:9. So basically is nothing but, if the ratio of the intensity is to be find out, it is nothing, 4 square by 9 square, that is 16 by 81. This is the ratio of the intensity. But from here we can't find the ratio of the frequency because frequency is not dependent on the amplitude of a wave. Then coming to the next problem, two waves of same pitch have amplitude ratio 2:3. Ratio of loudness and intensity is the same thing, as you know, they are directly proportional to intensity and the loudness are more or less directly proportional. And it's basically amplitude so the same formula will be applied over here. Loudness is square, directly proportional to the square of the amplitude, and the frequency is same because of same pitch. Same pitch means frequency will be 1:1. Same pitch, so you can't distinguish between which is shriller or which is softer. So this is the same pitch means same frequency. Next comes the echo problem. That the same problem. These are some problems that you guys need to know again, time period equal to 1 by frequency. These formulas you know is common formula. Number of vibrations. The number of vibrations is equal to frequency into time. How much time is taking, how much frequency the vibrations, how much it is happening. This is wavelength, lambda wavelength. Wavelength is equal to the velocity by frequency. Echo. This formula you need. This is very important for each and every sums of sound that will come in your examinations. And over here also this same formula will be applied, like a man standing between two cliffs produce a sound, interval 3 and 4. Over here T is 3 and 4, it will be again t. So you have to calculate the distance between the cliffs. So if this is the two cliffs and the man is standing over here, then you have to calculate what can be the distance between the two cliffs. You guys calculate it and tell me in the comment section. Then number 4, pendulum has a frequency of 5 vibrations per second. So 5 vibrations per second, you can use this formula, time period equal to 1 by the frequency time period. So if you need to know the time period over here, as the pendulum because it's the time period, like how much time for it's taking for one oscillation. So 5t by 1 by 5, you can find the time period. Then the pendulum is being started and observer is looking at, and started the pendulum, and so observer is hearing the echo after 8 vibrations from the cliff. After 8 vibrations, the observer is hearing an echo. Then find the distance between the cliff and the observer. So 8 vibrations it is hearing. So you can say 8 vibrations is happening between the two, and so the same formula is being applied over here. Same formula. So guys, I need you guys to solve these problems and tell me the answer and what can be the solutions. If you have any problem, write me in the comment section. I will try to give you more problems in the upcoming videos. And you guys are having examinations like during this pandemic as well. Till date, you guys are having your examination in May and June, July and all. So keep on practicing, keep on studying. Till then, share the video, share the knowledge. Stay well, stay safe.